Good day everyone, my name is Murugan. Today I would like to discuss about introduction for group project. The title we choose for our group project is Injection Molding by Ultrasonic. First of all, what is injection molding? Injection molding is a specific and cost-effective method of producing large quantities of plastic products. Injection molded parts do not require any post-processing and have the advantage of being net shape. Furthermore, injection molding can be used to create a wide range of products that vary greatly in size, complexity, and the application. The injection molding process necessitates the use of injection molding machine, raw plastic material, and a mold. Moreover, this is the most popular process in the manufacturing industry because it can produce complex shaped plastic products with high dimensional accuracy and short cycle times. Next, what is ultrasonic molding? Ultrasonic molding is imaged as a promising duplication technique for low and medium volume production of miniature and micro scale parts. Ultrasonic molding can process a wide range of polymeric materials in a relatively short time cycle without noticeable thermal degradation and with significant energy saving. Furthermore, the feeding system has been reduced in size and can be simplified to waste less raw materials.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Wan Muhammad Hafiz and I will present for the chapter 2, that is literature review for plastic manufacturing process. So, first is injection molding and second is ultrasonic injection molding. Okay, for the injection molding, injection molding can create components from the greatest diversity of materials in size ranging from microscopic to extraordinarily big. For connecting and attaching which other component, both plastic and non-plastic injection mold part can be exceedingly accurate and have a range of mold-in characteristics. The method is also adaptable to other variations, such as the ability to inject two or more materials into the same tooling during the same cycle for the production of a single part. In certain cases, injection mold components are utilized for additional processing. For example, they may be used for stretch blow molding, overmolding in a subsequent injection molding operation, or to be machined to add a feature that could not be formed in the first shot. For the application of injection molding, so from the past journey, we take microfabrication and food industry. First is microfabrication. When molten materials is injected into a mold and allowed to cool, the material takes on the shape of the mold. This process is known as injection molding. A heated barrel receives thermoplastic material, which is then put into it, where it melts and becomes soft. Then pressure is applied to this liquid material inside a mold cavity. The thermoplastic glass transition temperature is then lowered, resulting in the formation of a solid substance. This method enables thermoplastic microfabrication for mass production that is affordable. For the food industry, food industry injection molding also involved in food industry because plastic items such as packaging or closures are manufactured via injection molding. Thermoplastic components are put into the hopper, melt, and then pressed into mold as viscous fluids. Ram injection and screw injection are two important varieties of injection molding. The latter consists of a small extruder with a screw that goes backward and forward together and push the molten plastic into the mold cavity, as opposed to the former, which employ a piston to force molten plastic into the mold. Mold cavity are filled with the molten plastic and pressed into predetermined forms. Injection molding efficiently creates unlimited type of packaging forms because to the adaptability of mold design and manufacturing process. For the reaction injection molding, reaction injection molding is a relatively recent technique for creating such structured plastic form. This procedure involves mixing highly reactive plastic liquids under the pressure before injecting the mixture into a mold where it reacts, polymerizes, and forms polymers. The kind of quick polymerization reaction needed for this procedure works well with a variety of polymer, including polyester, epoxy, nylon, and vinyl monomers. Okay, the reprocess use relatively moderate injection pressure since the reactant have a low viscosity. Okay, the machine could therefore create a molding with a substantially larger projected area as compared to a normal injection molding machine with the same clamp force. Okay, next is ultrasonic injection molding. Okay, ultrasonic injection molding is more productive than conventional hot embossing because it doesn't require the mold to be heated and cooled repeatedly. Okay, it also uses less material and energy than injection molding because it doesn't have a complicated flow channel design or need its external heating device. Okay, the overall mechanical characteristics of the sample method using the ultrasonic injection molding technique were not only on par with those made using the injection molding process, okay, but even show a noticeable improvement. Okay, more choice for processing polymer material are not available because to the effective application of ultrasonic injection molding. Okay, so lastly, this is an illustration of the ultrasonic injection molding process. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Zul Khairul bin Abdul Karim. My matrix number CD1900259. Today I will present to you the methodology. Our team has chosen to start by doing some study on the origin and description of the plastic manufacturing process. Websites, journals, YouTube video, and other types of media are some of our resources. We have identified 10 articles and journals connected to the plastic manufacturing process. Then we have choose one of the 10 articles that were relevant to ultrasonic molding technology. Therefore, we have found out the main factor of the ultrasonic molding technology, which is the amplitude of the sonotron, frequency, compression pressure, injection velocity, raw material shape, and ultrasonic time.
Assalamualaikum. Hi, my name is Wan Muhammad Faiz. My matrix number is CD190101. I will further explain the methodologies involved in this research. Okay, first is the amplitude of sonotrope. This would be the ultrasonic amplitude that is delivered to the polymers. This amplitude is directly related to the maximum strain induced in the polymer by the vibrating sonotrope. It is one of the main factors to be considered when studying the ultrasonic molding process. Next is frequency. All elements must be in tune at the same frequency. In the recent case, very few information is known about the effect of the frequency in the ultrasonic molding process. However, we do know that the viscoelastic heating rate increases with frequency, but it only has minimal influence on the temperature of the polymer. Now, compression pressure would be the pressure at which needed to push the polymeric melt into the mold cavity. But too much pressure can lead non-melted material into the mold. Too little pressure can produce incomplete and inhomogeneous parts. For injection velocity, it is a newly added alternative to control factor of compression force. Here we have raw material shape. We should consider the right shape for this type of molding. It is one of the most important factor to process ultra-high molecular weight polyethylene, also known as UHMWPE. And lastly, we have the ultrasonic time. This would be the time which the sonotrope is vibrating. This is directly related to the energy applied to the material and also one of the most important factors for ultrasonic molding.
Next slide is about ultrasonic molding process main step. The first step is material feeding, which is to count and place the material in the plasticization chamber. The dosage of the material can be set manually or by using an automated feeder system. The second step is polymer heating. Once the polymer is placed in the plasticizing chamber, the upward advance of the plunger and compress the pellets against themselves. The third step is filling the cavity. The filling stage takes place simultaneously with the heating. Once the first polymer layer has melted, the downward movement of the sonotron or the upward movement of the plunger against the material. Next step is packing, when a holding force is applied to the polymer to compensate the shrink edge and to assure the correct geometrical properties of the sample. Last step is cooling. During this stage, the polymer injected is cooled down inside the mold from the melting state to the demoulding temperature.
Hello and a very good morning. I be our Dr. Prof. Yusri. So today I'm going to talk about discussion, but before that, let me introduce myself. My name is Victor Sanjalo, anak Mari Pramus, with the metric number of CD 190117. So today I'm going to talk about a discussion. Okay, so for this part, main factors such as amplitude of sonotron, frequency, compression pressure, and injection velocity are going to be discussed. Why? Because this is due to the fact that in this project, the application of electronic molding as added value as technology to manufacture more than one type of polymer. So going to our first point, the amplitude of sonotron. The higher amplitude values result in better filling and geometry accuracy. According to the literature review, the amplitude interact heavily with the other factor governing the manufacturing process, such as compressed pressure or velocity, as well as the shape of the polymer pellet. And next is the frequency. The calculated rate of heat generation at various frequency using the same amplitude. The result shows that in that case, the viscoelastic heating rate increases with frequency, perhaps with a limited influence of the polymer temperature. And then that we're going to talk about the compression pressure. So the pushing of polymetric metal into the mold require pressure, but the higher the however, the excessive pressure can introduce non-melted material into the figure, resulting in incomplete and homogeneous part. So the higher the force, on the other hand, appear to provide better filling ratio and dimensional accuracies of the sample, despite the fact that no relationship has been discovered between the pressure and the mechanical properties of the sample. And last but not least, the injection velocity. Lower velocity produce more bubbles, while higher velocities produce higher mechanical strength but unfilled sample. When processing polypropylene with increasing sonotron velocities, provide better filling result. When processing through molecular weight polyethylene with configuration 2, the U-shaped velocity provide better tensile strength. Although there is no clear experimental relationship between electronic molding parameters and the evolution of temperature during the process, a recent study with sensorized mold shows that the higher plunger velocities have less dispersion in temperature values obtained from the infrared sensor placed in the mold cavity. So I guess that's all for me. Thank you.
For conclusion, in this work, our group makes a project that refers to the research about injection molding by ultrasonic in manufacturing. From the research, we all know that about the ultrasonic molding process and what the advantage and disadvantage of the system. Ultrasonic molding technologies have emerged as a promising duplication technique for the low and medium volume production of miniature and micro parts. Furthermore, the processing of novel engineered and nanomaterials, understanding and control of the ultrasonic plasticization process, and tooling and equipment development research lines were identified as among the most important research areas that could lead to significant process improvement and innovative application in the coming years. Thank you. That's all from me.